I'm going to show you the same multiplication problems in 3 different methods. We'll start with a very easy one where we don't have to carry during the multiplying. The traditional method says let's start with this 2, which really is a 2, and send it against all of the other upper digits. 2 times 4 is 8. 2 times 3, which is really 2 times 30, is 60. And we can just write 2 times 3 is 6, because again the place value moves over appropriately, so this really is 68. We're done with the 2. Now we're putting in a placeholder. Why do we put in that little 0? Because this isn't a 1, this is a 10. So when I do 1 times 4, it's really 10 times 4 for my answer of 40. Finally, 1 times 3 is 3, which is really 10 times 30 is 300. When I'm done with that multiplication sequence, then I add up my things. 8 and 0 is 8, 6 and 4 is 10, 3 and that 1 carried from the 10 is 4. My answer is 408. There's a box method, often called a lattice method or a rectangle method, where I'm going to take a rectangle and I'm going to divide it up into sections based on my numbers. This is a 2-digit number, 34, and I will write it as 34. This is a 2-digit number, 12, and I will write it as 10 and 2. If I had more digits, I would need more subdivisions. Then I can take each box, and it's completely separate from all the other ones. So 10 times 30 is 300. 10 times 4 is 40. 2 times 30 is 60. And 2 times 4 is 8. When I'm done with that, I need to take all these numbers and add them up. We have the 300, the 40, the 60, and the 8. Four and 6 is 10 yet again. 3 and 1 is 4. Same answer, of course. If you look at these side by side, you can see that this method makes all those hidden zeros very obvious. This yellow 3 really is a 300, and now you can see it in the middle. This green 6 really is a 60. This red 4 really is a 40. You can see all of that happening there. The last method you've probably never seen before. It was invented by Lewis Carroll, the author of Alice in Wonderland. And he says, I am again going to write 34 times 12. I'm just copying it from on the other side. And then he does a strange thing. He takes an index card, a nice stiff 3x5 card, and he takes the top number and he writes it on the index card backwards. We're going to simulate that here on the computer. Once we have that, and I again need to copy and paste it to be an image, because images can cover up other images on my thing. Now, I have an index card with the top number written backwards. So let's start sliding it to the left, and every time there's numbers on top of each other, you multiply straight down. 4 times 2 is 8. There's nothing over this 1, so we just skip it for now. Then I slide the card another step. Here I have two things happening. So I need to add them together before I write anything. 3 times 2 is 6. 4 times 1 is 4. So 3 times 2 is 6. 4 times 1 is 4. And I'm going to add them together. And I get 10. And so in this method, if I have a 2-digit part, I will put the second digit diagonally down from the first one. I'm also going to color code to remind myself that this 10 came out of a 60 and a 40. Then we slide things again. Now there's a 3 on top of a 1, so 3 times 1 is 3. It doesn't have 2 digits, so I don't have to have any diagonal stuff. And when I'm done, I add things up, and I again get 408. Stare at those, rewatch the video sometime if you want to compare them again, and let that sink into your brain. But for now, let's do this with a problem where there's some carrying inside the multiplying. Make sure these still work. I am going to grab my box though. Take a shortcut of copying it over. Okay, let's start with on the traditional method. 9 times 5 is 45. 5 times 7 is 35. But I'm not going to write 35. I'm going to include this 4 and make it 39. I've used up the... That's all for this 5. So now we move on to the 2. We put our little place value holder because it's really a 20. 2 times 9 is 18. 2 times 7 is 14, and we'll include this 1 to make 15. When I'm done, add things up. And I get my answer. I still have 2-digit numbers, 79, 25. So this is still a 2x2 grid. And I will again fill in all the spots. 70 times 20, 7 times 2 is 14, and there's 2 more zeros. 20 times 9 is 180. 5 times 70 is 350. And 5 times 9 is 45. When I'm done, I add them all up. Five and 4 is 9, and 8 more will make 17. 4, 5, 6, 7, 8, 9. And unsurprisingly, I get the same answer. Oh, that didn't quite work. 79, 25. My screen snipping takes a little while. There we go. An index card. First number written backwards. Okay. Thank you for your patience with that. So now I have my multiplication problem. I have my top number written backwards. So I will start with lining up my first column. 9 times 5 is 45. And again, if I have a tens digit, it goes in the diagonal below row. Now I have two things. 7 times 5 is 35. And 9 times 2 is 18. Again, you could do this in your head, or if you don't do it in your head, just write it out. So we had 53, so the way we write it is 53, right? The tens digit goes down to there. And I'm going to remind myself that this included both my green and my red numbers together. Then I slide it again. Now there's only one number lined up above the other. 7 times 2 is 14. When I'm done, I add them all up. And I'm done. So now you know more ways to multiply than most people. If you're curious about what happens with this method when the numbers are very large, you could eventually need more than 2 rows there, but it won't happen with most school amounts of problems. The book that you could look at is the Lewis Carroll Picture Book, in which he describes this about on page 200.